All right, 18-0. Please make sure you are taking notes on ion formation. So, no, you should be taking notes, not pictures. When atoms transfer electrons, they form ions. Some atoms gain electrons, some atoms lose electrons. For instance, sodium is going to lose an electron. Chlorine is going to gain an electron. In the activity that we just did, we saw that sodium forms a +1 charge. It forms a +1 charge because it loses an electron, in which case it has not enough electrons to cancel out the protons. In this activity that we just completed, we saw that chlorine has a -1 charge and forms chloride ion, meaning it has extra electrons. Well, when sodium chloride salt forms, which you saw in the video, that is precisely what's happening. Sodium is losing its electron, and chlorine is gaining the electron that sodium lost. Okay? Look at this slide. On the left, it says metals typically gain electrons to become positive cations. That's a new word for us. Make sure it's written down. Cation. Cation. A cation has a positive charge. That's what metals typically do. Remember how many metals we have on the periodic table? More than half of the elements. Everything to the left of the staircase is a metal. All of those, when they ionize, are going to form positively charged cations. The nonmetals to the right of the staircase have a tendency to instead gain electrons. When they gain electrons, they form anions. Anions. An anion, another new term, is an ion with a negative charge. And then, as I already mentioned, we use the suffix "ide," which means similar to. We don't have any notation for cations. We just say the word ion. So if I say something ion, like sodium ion, I can assume that it's going to be a positive ion because it does not end in "ide." Whereas chlorine, I have to change it to chloride to specify it as an ion. And when I see the ending "ide," IDE, that means it's a negative ion. So we have sodium ion and chloride ion. I don't even have to say the word ion, to be honest, when I say chloride. It's assumed. We know what we're talking about. So the reason why these substances form ions to begin with is because of the octet rule. The octet rule states that atoms react by gaining or losing electrons in order to get 8 in the outer energy level. Logan, please make sure your mask is off. So we want to make sure we have 8 electrons in the outer energy level. Let's first look at sodium here. We have 1, 2, and 3 energy levels for the electrons. Some scientists might refer to these as shells, energy shells, electron shells. Sodium has just 1 electron in that outer energy level, that outer shell. Think of it like an onion, okay? Onions have layers that you could peel away and expose more complete layers. You know, the outside of an onion, it's always like crumbly, and that outer layer, it's not complete, it's full, it's flaking off. But if you remove the outer layer, then you have a complete layer that's exposed down below. Okay, it's kind of like an outer skin. It's the same thing with electrons. Sodium has that flaky outer layer that's not complete, that's falling off. And that outer layer consists of 1 electron. Sodium doesn't want just that 1 electron in the outer energy level. It wants 8. All atoms want 8. This is the octet rule. All atoms want 8. So what can sodium do to get 8 in the outer energy level? There's 2 options. Gain 7 more to complete the outer energy level, or lose 1 to expose the next energy level down. What do you think sodium is more likely to do? It's more likely to lose 1 to expose that next layer down, which has 8. Count them up. 1, 2, 3, 4, 5, 6, 7, 8. So what does sodium do? It loses 1 electron. It ionizes and becomes a positive 1 charge. It becomes an ion. What happens with chlorine? Chlorine has 2, 4, 6, 7 in its outer energy level. It wants 8. It can do one of 2 things. It can lose 7 and expose the next layer down, which has 8, or it could just gain 1, right? If it gains 1, then it has 8. And so that's what chlorine does. It gains 1 and becomes a negatively charged ion. Guess where it got that electron? It got it from something that's trying to lose electrons. Nonmetals want to gain to complete. Metals want to lose to expose the next layer down. Metals have a tendency to lose electrons to become positive. Nonmetals have a tendency to gain electrons to become negative. And that's exactly what we saw in the reaction between sodium metal and chlorine gas. Electrons are being transferred from the sodium metal to the chlorine atoms, and then we were forming these ions, sodium ion and chloride ion, to form sodium chloride salt. And that's chemistry in a nutshell. Chemistry is literally just the study of how electrons are interacting. Okay? So the octet rule, everything wants 8. Metals lose electrons to become positively charged cations. Nonmetals gain electrons to become negatively charged anions. And we switch the ending to "-ide" when they do that. Here's a periodic table. Metals in yellow, nonmetals in blue. Nonmetals gain electrons to become negatively charged. I've labeled the columns. Noble gases. Remember, noble gases don't react. That's why they're called noble gases. Well, what charge do they adopt when they react? Well, they don't react, so they don't get a charge. Their charge is 0 by default. They're not going to react. The next column over, however, fluorine, chlorine, bromine, iodine, are halogens, are highly reactive halogens. We see chlorine popping up. All of these ones happen to have 7 electrons in their outer energy level. All of these in this column will gain 1 to get a -1 charge. The next column over, the chalcogens, oxygen, sulfur, selenium. These ones have 6 in their outer energy level. They want to gain 2. When they gain 2, they have 2 extra electrons. 2 extra electrons, -2 charge. Next one over, the pnictogens, phosphorus and nitrogen. Notice I'm not listing arsenic, and I'm not listing antimony and bismuth. Why aren't I listing those? Because arsenic and antimony and bismuth are metalloids and a metal. They're not the same as the nonmetals nitrogen and phosphorus. So nitrogen and phosphorus have 5 electrons in their outer energy level. 5. To get 8, they want to gain 3. When they gain 3, they have 3 extra. They form a -3 charge. And then the next column over, the tetrails, the only nonmetal in the tetrails is carbon. Carbon has 4 electrons. Carbon can either gain 4 or lose 4. If it gains 4, then it's going to form a negatively charged anion. If it loses 4, it's going to be forming a positively charged cation. Carbon can go either way. Okay? But if it gains the 4, then it's a negatively charged anion. So all of those blue nonmetals, I could list them all. carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, selenium, bromine, and iodine. I can also throw hydrogen in there too. All of those metals, nonmetals, all of those nonmetals can form negatively charged anions. Everything else in the periodic table, metals, they're going to form positively charged cations. Remember, if we form a negatively charged anion, we have to change the ending to "ide." Remember, we had chloride. Fluorine becomes fluoride. Bromine, bromide. Iodine, iodide. Selenium, selenide. Sulfur, sulfide. Oxygen, oxide. Phosphorus, phosphide. Nitrogen, nitride. Carbon, carbide. Hydrogen, hydride. I just changed the ending to "ide." And when I change the ending to "ide," I'm specifying that it is the negative ion form of the element that I'm talking about. When things form ions, they're going to change in size. But that makes sense to us, right? Think about my onion example. If I'm removing that layer on the onion's becoming smaller. Well, which one was removing that layer? The metal was. It was trying to lose the electron, lose that outer layer. Well, when metals do that, they become positively charged and they get smaller. They get smaller because they're shedding that outer level. And on top of that, they're getting smaller even more so yet because now there's less electrons because we lost some. If there's less electrons and there's the same number of protons, we can't touch the nucleus. Now those protons are sucking those existing electrons in closer. Why? Because of the attraction between the positively charged protons and the negatively charged electrons. If there's suddenly less negativity on the outside, the positive can pull those in closer. So metals, when they form positively charged cations, they get smaller. Look at this. Sodium goes from 186 picometers to 102 picometers. Not quite half the size, but it's a substantial difference. Negatively charged ions do the opposite. Negative are nonmetals, they want to gain electrons. If they're gaining electrons in the tug of war between the protons and the electrons can start pulling away a little bit further. Look at this. Chlorine goes from 100 picometers as a neutral atom to 181 picometers as an ion. So negative ions, the anions, we're adding electrons so they get bigger. The positive ions, the cations, we're taking away electrons, we're shedding that outer layer, they're getting pulled in more closely, they're getting smaller. Cations get smaller, anions get bigger. Remember our trend in atomic radius? These are all neutral atoms. The biggest atoms on the periodic table are at the bottom left. Cesium, barium, rubidium, strontium, those are our big ones. Trend in atomic radius decreases as we go away from that bottom left corner. Here's the trend for the ions. Notice the difference. Our nonmetals forming negatively charged anions, vastly bigger. We'd see that huge disparity. Look how much bigger the negatively charged ions are compared to the positives. And they're in the location that we predict. They're on the right side of the periodic table. Okay. But if you look closely, amidst the positively charged cations, that trend still exists. As we move away from that bottom left corner, they're getting smaller. Within the negatively charged anions, the trend exists. As we move away from the bottom left corner of the section where the negatively charged anions are, arsenic, tellurium, as we move away from that corner, they're getting smaller. So the trend in size in the periodic table still exists even for the ions. That's it. That's it for ion formation. Okay. So it is 10:38. We have 10 minutes left in class. I have a homework assignment for you. There's 10 minutes to work on it, though, first. It's the 18.0 worksheet 1. Please add this to Notability. I don't want any excuses over the weekend that you didn't have internet. Add it to your Notability right now. Let's go over the directions so we know exactly what we're doing. So the first section says complete the following. For each of the positive ions listed in column 1, use the periodic table to find in column 2 the total number of electrons that the ion contains. The same answer may be used more than once. Okay, so this is matching, but we could have repeats. Matching with repeats. Write that down. Matching with repeats. So what are the steps in doing this? First, find the element on the periodic table. The atomic number is the number of protons, which is also the number of electrons in the neutral atom. So I need to take that into consideration with the charge. So the charge tells me how many extra or how many electrons I am missing. Since these are all positive, it's telling me how many electrons I'm missing each time. So this first one, aluminum with a positive 3 charge, I need to grab a periodic table and I need to find the atomic number. Okay, aluminum on the periodic table, atomic number 13. 13 protons, 13 electrons in a neutral atom. Positive 3 charge means I'm missing 3 of my electrons. If I have 13 electrons in a neutral one, but I'm missing 3, my answer is 10. So the answer here is B. That's a big B. Oh, it's bolded, that's why. There we go. Doesn't make any better. We need size, what, 14? 16? 16 ought to do it. Perfect. So number 1 is B. Again, I could repeat that number 1. I mean, that letter B. Let's go to the next section, number 2. For each of the following ions, indicate the total number of protons and electrons in the ion. This one's much of the same, it's just set up a little bit differently. Find the number of protons by finding the element on the periodic table, and then determine the number of electrons based on the charge. So if I look at a periodic table, I find cobalt, which, by the way, what's the difference between CO and CO? Naraya says that's carbon and oxygen, and she's absolutely correct. CO is the toxic gas, carbon monoxide. C(o) is the element cobalt. Who said capitalization doesn't matter in your element symbols? They do. It's very important. Okay, that was just a little tangent. So if I find cobalt on the periodic table, it's atomic number 27. So therefore, it has 27 protons. This has a positive 2 charge, which tells me I'm missing 2 electrons. 27 minus 2, I have 25 electrons. These are all positive charges, so all these will have more protons than electrons. Number 3, for each of the following atomic numbers, use the periodic table to write the formula, including the charge for the simple ion that the element is most likely to form. So this is atomic number 53. If you had a periodic table in front of you and you found atomic number 53, I need to just pull up a periodic table, but it's iodine. Iodine is in the column that is most likely to form a -1 charge. And so I'm going to signify that it has a -1 charge. That 1 is not necessary. I could just put negative and the 1 is assumed, but I'm going to put it there anyway. Atomic number 38, strontium. Strontium is, I'm in superscript mode. Strontium is most likely to form a positive 2 charge. I know that strictly from the location on the periodic table. Number 4 through 9, actually 4 through, they're all a little bit, 4 through 8. Write the chemical symbol for the ion with 12 protons and 10 electrons. Well, 12 protons, that's going to be neon. No, that's not neon, sorry. That's magnesium. So that's going to be magnesium, Mg, but it's missing 2 electrons. It should have 12, it's missing 2, so therefore it's going to have a positive 2 charge. Okay, that's what I'm going to do for 4 through 8. 9, how many protons, neutrons, and electrons are present in this symbol? Well, the protons, I have 28. It's explicitly written below there. The number of neutrons, 59 minus 28, because remember the mass numbers, protons plus neutrons, 59 minus 28. So I have 31 neutrons. And then electrons, well, I should have 28, but I have a positive 2 charge, so I'm missing 2, so 26 electrons. I do that for 9 through 13. And then you're going the other way with 14 to the end. Write the complete chemical symbol for the ion with 84 protons, 125 neutrons, and 80 electrons. Well, 84 protons, if I find that on my periodic table, I have polonium, P-O. Well, it's hard to do symbols and typing. For the mass number, protons plus neutrons. Okay, so I have 125 plus 84. So in my head, I do 120 plus 80 is 200. And then I have the 5 and the 4 left over. So I have 209 for the mass number. That is much too large. And then for the bottom number, that's the number of protons, and that's explicitly given to be 84. And the last thing is the charge. 84 positively charged protons, 80 negatively charged electrons. I'm missing 4 electrons. So I have extra positive. So this is going to be a positive 4 charge. That's what you're going to be doing for 14 through 17. Okay, this is 2 sheets worth, but once you get into a system for each section, they go really quickly. And then, of course, you have until Monday to do this. Okay, so that is your homework assignment. Do a couple more before the end of class, and then have a great weekend.